Hello, welcome again. We are solving some conventional questions of power plant. The topic is steam turbine. Question number 48 from Civil Services Mains 2015 is the angles at the inlet and discharge of the blading of a 40% reaction steam turbine are 35 degrees, 35 degree and 20-degree respectively. The speed of rotation is 1500 rpm, and at a particular stage the mean ring diameter is 0.67 meters and the steam condition is 1.5 bar 0.96 drive. Estimate 1 the required height of blading to pass 3.6 kilogram of steam, and 2 powered bulb by the ring. Assume at 1.5 bar pressure is VF pressure. VF is equal to 0.001052 meter cube per kilogram and VFG is 1.15937 meter cube per kilogram. So we know that in reaction turbine, absolute velocity at inlet is equal to relative velocity at outlet, and absolute velocity at outlet is equal to relative velocity at inlet. Angle with the absolute velocity at inlet is the blade angle at outlet, and blade angle at inlet is equal to angle with absolute velocity at outlet. So in symbolic means V1 is equal to VR2, VR1 is equal to V2, alpha is equal to beta 2, and beta 1 is equal to delta. This is the inlet velocity diagram. This is absolute velocity. This is blade velocity, and this is world component of velocity. This is flow component of velocity at inlet, and this is your relative velocity at in x direction, and this is total relative velocity, and this is blade angle. Okay, and outer velocity diagram is this is relative velocity at outlet. This is absolute velocity at inlet. This is blade angle at outlet, and this is angle with absolute velocity at outlet. This is blade velocity, and this is work component, and this is flow component, and this is VW plus U. VW plus U. And given that the RPM is 1500 RPM and blade velocity is 5 dn by 60 and diameter is 0.67 meters and n is 1500 rpm. So blade velocity is 52.595 meter per second, and alpha is equal to beta 2 is given as outlet velocity, blade velocity angle is given as outlet blade velocity angle is given as 20 degree. So alpha is 20 degree, and inlet blade velocity angle is 35 degree. So beta 1 is 35 degree. Okay, so this is your delta, and this is 35 degree, this is alpha, this is beta. Okay, so these angles are known. Okay, and velocity u, blade velocity u is known. U we have calculated. Okay, now from this triangle A, B, and C, alpha is 20 degree, and beta 1 is 35 degree. So we can calculate this angle ACB. That will be 180 minus 35, that is will be 145. Okay, and now we have two angles of the triangle. We can determine third angle. Okay, so third angle will be at 50 degree. Okay, so now using sine law, VR1 by sine alpha is equal to V1 by sine 180 minus beta, or beta 1, or we can say 145. So u by sine 45 or sine 15 and V1 by sine 45 are equal. Okay, angle opposite to u is this, it's sine. Okay, and angle opposite to V1 is sine are equal. So u is known, so we can find out V1. So V1 will be 116.557 meter per second. And now from V1 we can determine the bulk component, so that is V1 cos alpha or cos 20, and VF1 is 116.557 sin 20. So this is for flow component. Okay, So now V V2 is equal to VR1, and from this VW1 and U1 U we can determine VR1 also, or we can say as V2 is equal to VR1 and alpha delta is equal to beta 1, so V2 cos delta will be equal to VR1 cos beta. So VR1 cos beta is this quantity, VW1 minus cos of this. So VR1 cos beta is VW1 cos VW minus U, and this is VW2. So and power dwell with M VW1 plus VW2 into U. So we can put VW2 as this quantity and M as 3.6 kg and U as 52.595. So power dwell is 31518 watt. Okay. So this is the power dwell, and specific volume at 1.5 bar and 0.96 dry. We can calculate from VF and VFG that are given. VF is given, VFG is given, and dryness factor is given. So we can calculate specific volume. So specific volume is 1.140 meter cube per kilogram. Okay. So now we have calculated VF1 also. So VF1 is 116.63920, and reaction turbine is axial flow turbine. So area for this flow velocity is pi dm into hb. Hb is blade height and dm is 0.67. Okay, and VF1 is 116.63920, and specific volume we have calculated this, and mass flow rate. So this is your mass flow rate. So this is given as 3.6. So from this you can find out hb. So that is 47.8 mm or 0.0478 meter.